Well, good evening, everybody. Welcome to our meeting tonight. We've got a great guest, and it's going to be kind of a long presentation, so I would ask that everybody hold their questions till Jeff is done with his presentation. There will be a question and answer period, so we can have plenty of time to pick his brain. Just very quick background, Jeff is a president of Alliance Green Builders. You might remember at the last meeting with Pete Beauregard and his very incredible home. Well, Mr. Adams is responsible for that, but more important, he also does his company, along with his partner Rich Williams, they do a lot of green building throughout San Diego County. So he's here tonight to talk to us about green building in general, and it's a really important topic for us. So without further ado, I would like to introduce our guest tonight, Mr. Adams.
Thank you, Bill. It's the first time I've ever talked with a mic like this, but I titled this program, this PowerPoint presentation, Catch the Green Wave. I developed it about 10 years ago, or I'm sorry, about 7 years ago, when I started studying green building intensely during the financial meltdown and construction got real slow to almost non-existent. It gave me time to dive in and start learning about green building very intensely. And at the time, my company was Wavecrest General Contracting, so I titled it Catch the Green Wave because the logo had a green wave on it. Then about 4 years ago, I hooked up with Rich Williams, who was also going down the same kind of path in green building and in green knowledge. And together we teamed up together with the goal to be the green contractors in San Diego County. I unabashedly say that when I started studying it, it was very competitive when no construction was going on. So contractors were out of work. It was very competitive to find work. And so I decided to learn about green building to kind of distinguish myself from all the other contractors. But then once you learn what it's about, you become very passionate about it, that it's more than just green building, and I'll get into that and what green building means. And so a little about myself. I went to school at UC Santa Barbara, came back, born in San Diego, came back to the North Coastal because I was a surfer. And my very first project, I bought a house, bought a lot in Encinitas, and I bought a house in Escondido that the state had bought through eminent domain when they were putting in the I-15 freeway through Escondido. Shows how old I am. And it was 1972. And we hired a house, we bought one, hired a house mover, and put it together on the lot, and went from there. I did some more of those. And I look back on it, it's like, that's the ultimate recycle. You know, keep that whole house. And it's still there. So then I did new remodeling, new construction, and I did a couple of timeshare resorts. One in 82, 83 in Del Mar on the oceanfront, a timeshare called Wavecrest Resort, which is where I kind of named my company after that, Wavecrest. And then in 85, 86, Tamarack Beach Resort on the ocean in Carlsbad. But my main love is custom homes. I had a late brother that was an architect, and we worked well together because he designed them and I built them. And we got into custom high-end homes. So like I said, when I started studying green with the financial meltdown, it gave me time to dive in. Some of the things I've become certified since was Passive House Certified Builder, which is an intensive training program, LEED credentials, LEED AP for custom homes, and National Association of Home Builders has one also. I went through that certification. That's mainly used more on the Midwest and East Coast. Let's see. Okay. So the green movement is more than just single-family homes. It infects all building. You've got multifamily up there. You've got renovations and subdivisions. And the green movement started, actually, we didn't call it green then, but it was back in the 1970s, late 70s, when we had the oil embargo and gas was real expensive. You had to wait in line gas stations. You couldn't get gas other than every other day, things like that. But back then, at some point, the energy got cheap again. So all these green measures that, we didn't call them green then, but efficiency, energy efficiency, and so forth, kind of went away in the building industry. And I'll touch more on that later when it comes to passive house. But now it's come back, and this time I like to think it's here to stay, because you see, people are thinking green building for more reasons than just their pocketbooks. They're thinking about the environment, global warming. We didn't talk about global warming back then. Now, I ask the question, what does green mean? Green's a one-syllable word, and as humans, we like convenience. So we say green, but really it's synonymous with sustainability, a six-syllable word. So then you have to ask, what does sustainability mean? You can read these quotes. It really means, how do we live in a way today that doesn't affect the people that come after us? We like to say, we didn't inherit the planet from our parents, we're borrowing it from our children. In my life, I don't know about you, in my life, the most important thing to me is my children. So we're borrowing it from them. So in the future, we're going to have food to eat, clean water, functioning natural environment, and functioning economy. It's all about sustainability. It's not an option. I love this quote. It's an obligation. And I like this one too. It says, if we insist on ruining the planet, we have to stop saying that human beings are the superior species. What it is people say, well, we want to save the environment. Well, we're not trying to save the environment. We're trying to save ourselves. We're the ones that are going to perish from the planet, and then the environment's going to go on one way or another. So this was pretty telling photos I found somewhere of that's just like one person's lifetime. And that glacier's receded. And I don't have to tell all of you, I know you're all aware of this stuff, but it's pretty sobering that the rate it's going. Back at Hurricane Katrina, the thing about it wasn't that it blew harder than the others, it was just bigger than the others, bigger across. I can't remember how many hundreds of miles across it was, which had never happened like that before. So is there anybody here that is a global warming, in denial of global warming, like our president? There isn't any. I didn't think so. But if you come across anybody that is, I have proof for you that you can show them. Because how do you explain this? That's my humor to the thing here. I saw that in someone's presentation. I got to get that. That's funny. Okay, just a little bit about what's going on in California. By 2020, the goal, and these goals were set a while back, reduce to 1990 levels of carbon emissions, and all new homes are supposed to be net zero energy for all new buildings, residential. In 2030, all new commercial buildings, and to be 40% below 1990 levels, and by 2050 to reduce down to 80% of 90 levels. So it's a pretty, regardless of what our president does and pulling out of the Paris Agreement, California's going to keep them with it. I thought this was kind of interesting too. We think of cars, with their exhaust coming out and the smog off the freeways and things, but which gives off more carbon emissions, a car or a house? It turns out one house is about the same as two cars. Pretty interesting. So that's what gets me into the built environment. U.S. buildings are 40% of the primary energy, 70% of electricity consumption, and 50% of greenhouse gas emissions. So it's pretty important. Buildings are the biggest sector. You'd think of transportation and industry, but it's actually buildings. And of buildings, residential is more than half. This is the vast majority of the buildings that goes on. So in studying green, I'd hear all this stuff, VOCs and HRVs and dual flush toilets, and all this stuff was kind of jumbling around in my head until one day I listened to a guy talk about LEED and how to get LEED accreditation, the training for LEED. And he held up a prop. You can't see this very well, but that is, this is site, water, energy, indoor air quality, and materials. And the way he explained it, I'm going to put this down a minute. I'm going to set it right here. So, okay, you're going to have a site. You're going to put a house on the site. So everything that's green falls into these 5 categories. You have site, you have the house, where you put the house and so forth. This house is going to need water. Water is a rare commodity, as we all know, in California. And then this house is going to use energy. So you got site, water, energy. You know, it has to light the house, heat the house, and run appliances. And then indoor air quality inside the house. And lastly is materials. In this case, it's plastic. And I put that last because it's actually, in my mind, it's important, but it's the least of those 5 categories. But it's the one you hear the most, because when you have advertising products and magazines and TV, they're always trying to advertise how their product's green. And I'm capitalist. I'm not against capitalism, but with the marketing and ads and stuff, that's where you hear recycled content and a countertop and things like that. And I get clients in, and that's what they're thinking of right from the start, which kind of motivated me to create this PowerPoint to kind of educate them and what the other aspects are. So once I heard those 5 categories, everything kind of made sense. Everything you hear falls into those 5 categories, and I want to just briefly go through some of the issues in each of the 5, starting with site. This was a house I built in 1979 that I'm going to refer to quite a bit on these 5 categories. I didn't know it was called green back then, but that's back when energy was very expensive. It was a spec house that I had for sale. A little bit of history about interest rates, too. I had a spec house for sale in 1979, prime interest rate, not the mortgage rates, which are higher. Prime was 21%. You can imagine. So you think about these rates today when they go up 0.25%, it's like still really low. Okay, design. You know, green concepts are to conserve natural resources and maintain the wild habitat that's around there. You don't want to extinct things. What your solar exposure is on the site, things like that. And in site design, it doesn't cost anything to think about where to orient your house on this lot, and to think about what you're displacing when you put that house on there. So site development, minimize slope disturbance, and protect existing features and manage stormwater runoff. This house, that same house, was actually a 1/4-acre lot with avocado trees. It used to be an avocado grove, and so they were like, I don't know, 20 feet apart or something in a pattern. And we did everything we could to keep the avocado trees. There was just a few that weren't growing very well that we took down, and one of them we actually incorporated inside the house. But you can see here how we built decks around them, and that one there we even built that little wall to let the branch go through, and really protected the environment. This is a nice little sketch. It talks about how this house is facing south here, in the west in the summer, the west sun. These are deciduous trees, so you get the sun in the winter and you get the shade in the summer. And just things to think about. Like here it says, we don't really have this here, but on the north side it could block northern winds in the winter. I think of that more of other states, but this is that same house. You can see the tree that we carried inside. And I'm going to come back to some of these things on here, but you can see, where's my little red? It's such that in the summer, the sun hits down here, where in the winter, when it's lower in the sky, it hits on this thermal mass wall and heats it up. And I'm going to come back to that when we talk about energy. And that's a picture of it. That's the skylight right there. So green concepts call for building closer to the cities, you know, where your core community is, instead of urban sprawl. So homes and tracks are way outside. You got to drive miles to go see the theater, go to the grocery store, and so forth. It's just kind of trying to bring it in, infill lots, and urban sprawl is. I just talked about that. They're far away. Oh, has anyone heard of the happiness triangle? My daughter actually taught me this. You take 3 things, your home, where you work, and where you play, and connect them into a triangle. And in terms of distance, the smaller that triangle, the happier you are. I actually live in Cardiff, close to the Cardiff Community Center, and my office is 5 minutes away, and it is really true. Okay, let's see. I like this picture here because it shows south is down here, and every one of these homes has a southern-oriented roof to pick up photovoltaic cells. but it's not a boring rectangular grid of straight streets and stuff. It's pretty interesting. And what you can't see is it has a whole system of pedestrian walkways through it. And walkability is an important thing. As you can see these things up here, it really gives you a sense of community, and it cuts down on gas usage and stuff, and supports small businesses. So that's part of LEED. And moving on to water. 20th century, the world's population tripled, and its use of water grew 6 times. Well, you can go almost a month without food, and 12 to 14 days without a TV. I made that up for humor. Your body can't survive, it should be like cell phones now. Your body can't survive 1 week without water. It covers most of the planet, but just 3% is fresh, and most of that's ice, and most of that's inaccessible. Can't really read it on this thing here, but less than 0.07% is available to drink. So we can't impact our supply of water. What we can do is change the way we use it. And we do that in 3 ways. There's indoor water usage, efficiency, outdoor for our landscape and so forth, and our wastewater. So we do a very good job these days with low flush toilets, dual flush toilets, low gallons per minute faucets. They're mandated in California by code. And appliances now, washing machines now use about 18 to 20 gallons. They used to use 40 gallons of water. The dishwasher uses 25% of the water it used to use on these new dishwashers. But where we're really wasting a lot of water and not conserving it as much as we could is outdoor in our landscaping and so forth. But that's changing. All the irrigation companies have come up with really good, drip systems, use very little water. And there's types of sprays that use less water. They're doing a really good job in moisture sensing controls so that irrigation doesn't come on if it's rained and your soil's already wet. And then local native plants are important because they're used to living here, so they don't need very much water because they lived here before we did. And turf, they do have turf that's pretty low water usage these days, but typically regular lawns use a lot of water. There's places for lawns like parks, recreation for the public, but do we really need lawns all out in front just to look at them? You know, there's plenty of plants that don't use up all that water that could look just as good. And xeriscape is planting that doesn't require any, you kind of see it in the background, those kind of succulent kind of plants, doesn't require any irrigation. So then water conservation, you've got 3 things. Gray water is water, as you probably already know. It comes from your showers and your washing machine, and you can reuse that for irrigation. Rainwater is what we call the water we collect off the roof. And in Ramona out there, we collect that off the roof and use that for the domestic water inside the house. And then the water, you call it stormwater, the water that hits outside the house on the ground, and all your area drains, you call that stormwater. So you got rainwater, stormwater, and we use that for irrigation. And then black water recycling is coming in the future. We did it, the first one in San Diego County out there in Ramona. We got a permit to use both gray water and black water when we treat it and use it for irrigation. So that's going to be in the future. In Australia, they already are way ahead of us. That water just gets recycled. Any water they have, boy, they just keep it. They got ways of doing it. There's some water tanks collecting water off the roof. This house had a big flat roof. There's 2 5,000-gallon tanks. And then we dug these pits and kind of lowered them down so they weren't visually obstructive. The owner wanted to do that for his neighbors. It's kind of interesting. These are out in Ramona. There's 3 sets of tanks here, and those are each 10,000 gallons. You can see we camouflage them here because we put them up there. We actually have 9 of these on the site, and they're bright, shiny metal. When we put them up there, and the sun reflected off, and the neighbors came out of the woodwork. They're all up in arms, so he threw that out. Well, they're now painted, and we've got some pepper trees planted around them and stuff to mitigate that. This is kind of a complicated thing we put together on what we have out there, but just briefly, what we're trying to represent is the rainwater comes down and hits on the roof, and it goes into some storage tanks, and we bring it, treat it, filter it, and bring it back into the house, and it gets used. You can't see that, but it says rainwater, gray water, and black water. goes into the house, so it comes out as waste. It's gray and black, and it comes down to a normal septic tank and another one that specially treats it here, and we use it for irrigate the food forest out here with fruit trees and other herbs and stuff. And then water that hits the ground, stormwater, gets used to irrigate and also augment that water for the food forest. Okay, energy is actually, in my opinion, the biggest of the 5 categories. And we address energy in 2 ways. One is reducing the amount of energy required, and the other is using renewable resources. Now, you have energy conservation, you build your house in a way that you don't need as much energy. The cheapest energy out there is the energy you don't need. It's free. And then energy efficiency is decreasing the energy demand. Energy in homes, your mechanical is half the energy. That's the big one. Appliances and lighting are 32%, and water heating is about 20%. So this is a really important concept in terms of decreasing the amount. Like I said here, the big one was HVAC. To reduce your mechanical system and energy for it is really important and very inexpensive to do, is pay attention to this envelope. Here's your thermal envelope. And this is a very common house. Got an attic space up here. And we don't do this anymore, but we always put these up in there. It's a nice, convenient place to put it. It's up in the attic, but it's not a conditioned space. And I'll get to that later. So this is how it's supposed to go in theory. But what ends up happening is you have this very leaky house through all sorts of things I'll get into, and it just doesn't work that way. You get duct leakage, you get holes in the envelope, and it's like trying to fill a bathtub with the drain unplugged. In fact, the average house, like built in the 50s and on up there, the average house has duct leakage or equivalent to trying to heat your house with one window open in your house. If you can imagine one window completely wide open and you're trying to heat your house in the winter, that's what a typical house has, that much leakage in it. It was a big source, I keep hitting the wrong button, of recessed cans in the ceiling. This is your thermal barrier right here, and the air would leak around them, around outlets on the exterior. That's an infrared shot showing the heat loss there. Because they used to be, you could not put insulation up against a recessed can for fire reasons. Now they make cans that you can put insulation up against. And this was very typical. The electrician just chops a big hole in the plywood there, the exterior sheathing. And today we do it like this, where we make a nice clean cut and we put foam around that and just seal that up. Every opening in it, this is up in the attic. Instead of just chopping holes like this, and all that, either heated air or cooled air in the summer in your house, it's just going right up into that attic. It's like trying to heat and cool the outside. So now we make cleaner cuts and put foam around them. And that's all that thermal envelope. This is in Ramona, Casa Aguila, and this house here, this is liquid applied membrane. This is the waterproof membrane. We framed this house like this so that we could do this. This is before the eaves went on. The eaves, actually they're going on here, but the eaves were made out of SIPS panels. They created the eaves and added insulation up there. But that envelope, think of a balloon. You seal everything tight as a balloon around that thermal envelope. This is different colors because they changed, while we were putting it up, their product changed colors, so it made for kind of a funny looking building. And we were patching little holes in it. Passive house, this is a passive house. Passive house has a very strict test on airtightness. And so this is our first one. We wanted to make sure we sealed that all up, which we did. This is a little drawing. You can see, and you plan for this. Passive house makes you plan for this and submit them for pre-approval before you even build the house. And you outline where that thermal barrier is here. That's that red line right there. There's your thermal barrier. And it came up, what you saw was that right there on the plywood here and plywood here on the roof. And then this went on after that. So your thermal barrier is right in there. There's no penetrations right in here. The beam doesn't start in here and come out. It just attached to the outside, so you get that, like again, just like that balloon. There's that balloon. This is, I'll come back to this is phase change material. I'll come back to that, but this is showing blown-in cellulose. And what's nice about it is it just gets in so tight, all around pipes and wires, as opposed to fiberglass bats. This is the one I did in Leucadia, a LEED Platinum home. this is that she put in, the owner, double stacked washer and dryer. So there's 2 washers, 2 dryers stacked, and so you got all these vent pipes and all the drain lines. How do you put fiberglass bats and insulate that wall? That's an exterior wall. So we blew and blown in cellulose, and look how tight that is. And technically, cellulose and fiberglass bats have the same R value. The insulating rating, the R value is the same on paper, but it's no way that it would function the same. So the goal is to increase energy for heating and cooling. You want to design your duct so that you have efficient duct runs, and they're the right size. And you want to reduce leakage. You want to seal your ducts. And we put them in conditioned space. We don't put them up in an unconditioned. You got your duct lines going through a hot attic when you're trying to cool the house with air conditioning. It doesn't make sense. Same thing in a cold winter. You're trying to heat the house and your ducts are running through basically outdoors. And we have multiple stage motors. We got some pretty efficient heaters out there to choose from. This is a way not to do it. You can see there wasn't a lot of planning on that. In fact, one remodel I did for these people's house, went up in the attic, and the one duct was completely had separated. So when they turn on their heater, it's just heating the attic on one of the runs. It was crazy. Here's showing a good mastic sealing around. That's what you want to do. Nowadays we test the ducts too to make sure there's a very limited amount of leakage, not over a certain limit. So this passive solar, coming back to this, I mentioned this is a thermal block wall just like this, but right here, the south's over here. And in the winter it comes and hits that wall, warms it up, and then that can release that heat in the evening and at nighttime. But then you don't want that in the summer, and it's designed such that it'll hit the tree down here, but it doesn't hit the wall. I'll show you, this is, and also, design it, this is a thermal, what do you call it, chimney effect. The hot air in this big room is going to go up here, and when the thermostat calls for heating, the first thing that went on, this was back in 1979, first thing that went on was a recirc fan. It would take this hot air and recirc it, and it would blow it out down below, because this is where the humans are. We're not up there, and so it would blow it down there. Then, if that wasn't enough, the furnace would go on. This all kind of had these controls. The furnace would go on. In the summer, when it's hot, you open windows down below and open a damper on this duct, which is this one right up here. And you get this natural chimney effect ventilation, and this little thing turns and you get a little wind. It helps turn it and it draws it. You get some natural ventilation. And then if that's not enough, at the end of this duct on the exterior was a motorized exhaust fan that sucked that out. So you have your passive is just the natural ventilation, and then you have a little bit of active if that's not enough with mechanical. Use it was a real low energy motor. And then also we had, if it's too hot, a mechanical intake. It would blow air into the house from the north side of the house underneath the avocado trees where it's nice and relatively cool. And right where that intake was, we planted some gardenias, so you get this gardenia smell coming in the house. So it's really cool. This is one of my favorite projects. It turned out the avocado tree didn't make it. Don't ever do that. It turned out an avocado tree is not an good indoor plant. That's a whole other story. But here you can see the sun. This is in the winter. The sun's washing this thermal mass wall. And the thermal mass is what this is, this phase change material. Thermal mass, what it does is I like the example of the ocean compared to inland. Like in the summer, it's always like 10 degrees cooler right along the coast. You go in a few miles and it's hotter. It's because and then in the winter, we don't ever get frost on the coast, and then inland areas like I think Fallbrook and like Ranch Inland, you can get frost in the winters. It's different because during the day, the earth heats up, the surface of the earth heats up, and then cools down at night, and you get this big, if you graph it's this big swing. But the ocean doesn't do that. It just sits there at that one temperature. It changes its temperature over months, just based on currents. So it tempers it. So that's like a big thermal mass. That's the way I can think of it. So we used to put in, we've had these big boulders right there Let me go back. Right, keep hitting the wrong button here. These are thermal mass, these walls are thermal mass. And they're all insulated from the outside. It's all inside the house. And phase change we came across when we were doing Casa Aguila in Ramona. It just came out. It's little pockets of gel that changes. The house heats up. It'll absorb that heat by changing from a solid, that little gel, non-toxic gel, change from a solid to a liquid. And then if the house cools down and it calls for heat, at a certain set temperature range of 2.5 degrees each side of a certain temperature, say 75 degrees, 73 degrees, it occurs about within 2.5 on each side of that. It'll change from a liquid to solid, and that releases heat. And I'm told it's the equivalent of 19 inches of concrete wall of thermal mass, just those sheets, and those just go directly behind the drywall. So that kind of like this quote. Now, in the coastal zone, we're not in the coastal zone really here in Fallbrook, but if you're on the coastal zone, 95% of your heating and cooling could be met without mechanical. Okay, for hot water systems, it's important, it's code now to insulate your hot water pipes. We use recirc lines to have water there. That has to do with water efficiency, so you're not wasting a bunch of water when you turn it on, but they have different controls that makes that recirc. We used to let recirc at 24/7, but it turns out that doesn't work. It wears out your pipes. But, and that's more energy than you really need to do. Tankless water heaters, a regular gas-fired water heater in your garages and so forth, it's heat. When you're at work all day, it's keeping that water hot. It's using energy to keep it hot when it doesn't need to. That's like on demand for tankless. And then, of course, solar-assisted water heaters. Back in '79, when you said solar, it was all about hot water. We didn't have photovoltaic cells back then. And this is kind of interesting about electricity. There's two types of energy. There's the source energy, where it's generated at the power plant, and there's site energy by the time it gets to your house and you're using it. And there's this huge loss that's generally, this says, I got this from someone else, but it says it's 15%. I think that incorporates the energy to transport it, like coal's got to get to the plant, or oil from the Middle East has to get transported to Carlsbad SDG&E plant. But just from here to here, you have about a third of the energy that it took to generate back here. And it's kind of depressing, because there's a loss all along the way. There's a loss when you convert it from coal or oil to electricity. There's loss in the lines, loss in the transformers. So by the time you get there, but if you think about conserving energy you don't use with a good efficient house, for every unit of energy you don't use here, that's 3 times that's not being needed to be generated back here. So it goes both ways. So this was from, some of the ways we conserve. Low volt lighting systems are nice because you can dim them. They're really easy to dim. And you can dim it at 85% power. It's not perceptible to the human eye. So you're saving 15% right there. And then this was from years ago, when I made this. Really, LED lights, they were expensive then. Now they're not. They're really inexpensive, and there's no reason to not put if you're building a new home, it's not expensive to put all LED lights in. They're extremely energy efficient. And you can tell they are because when you touch them with your hand, they're cold. They're not hot. You touch a hot incandescent light bulb, you can't even touch it, and it's hot. That's energy waste. That heat coming out is the inefficiency. Okay, Energy Star appliances. I talked about it. Clothes washers use a lot less water, and dishwashers. And refrigerator, the biggest energy hog of the appliances is your refrigerator. And today's Energy Star refrigerator, compared, if you replaced a refrigerator you had in 1990 with an Energy Star refrigerator, I'm told it would save enough energy to light the average house, provide all the lighting energy for an average house for 4.5 months. But what you don't want to do when you replace it is do what I did way back, put it in the garage as a second refrigerator, because it's still drawing energy. I got this great refrigerator in the kitchen. So this one I thought was kind of funny. Just at what point does energy have to get expensive enough to go push for renewables. And renewable energy is, as you know, photovoltaic and solar hot water and electricity for PV, wind generation, geothermal, it's where you take advantage of the constant temperature down in the earth, and biofuels like from corn and so forth. And wind energy is the second fastest growing energy supply. There's a gentleman here who sells wind generators for half the price of what we paid for this. And it gets the same amount of energy. This one was like 3.2 kilowatts. But this is out in Ramona at Casa Aguila. And we kind of like this one. We had a hard time finding one. And there aren't, according to the guy I bought it from, there aren't a lot of good spots in San Diego, so be careful. He said San Diego typically doesn't have very many. But we tested this. This is right at the end of the San Pasqual Valley, comes up and makes a 90-degree turn. And the prevailing winds come right up that valley and right up this hill to this one. So he said after he tested it for a month, it was one of the best sites that he's ever seen in San Diego. And we liked the vertical access because when it turns, it creates a solid, it doesn't become invisible for the birds. They can see it and they avoid it. Okay, moving on to materials, the last of the 5. How am I doing on time? Reduce, reuse, recycle. Let's kind of think about paper in your office. A lot of people, you can email. We don't have to use paper. If you don't have to use it, that's good. And then if you do use it, you can keep your scrap paper and use the other side. That'd be like reuse. And then, of course, when you're done with it, you can recycle it. These are some bins we put on job sites to recycle all the materials from waste materials. So it's important to design for durability. You want products that last a long time, so you don't have to, it's a lot less maintenance costs, and it's just better all the way around to have. There's lots of materials that are real durable these days. And incorporate, there's a reason for roof overhangs. A lot of modern buildings have no overhangs and stuff, but there's a reason for them. And flashings, it's moisture management, it's really what it's about. Low maintenance materials, and then of course, trying to build in a way that you don't have, we used to have piles of waste and like lumber, this big pile after you frame the house, but nowadays we plan for that ahead of time and have detailed drawings, detailed takeoffs, and try to reduce that waste. So it's all about using less materials. You can deconstruct buildings rather than demolish and reuse salvaged materials. This is a job we did in Encinitas that it's a gut remodel, took it down to the studs, but all these products, there's companies out there, the reuse company, they'll come in and give you an appraisal of all the windows and appliances and doors and light fixtures and plumbing fixtures, and they actually give you a tax credit for it. They come in and take it out, and then they reuse it and sell it. In some places, stores, they have Habitat for Humanity and so forth, and you get tax credits for it too. So the concept of cradle to cradle, we grew up creating products that go cradle to grave. We take a chair or a lamp, use it in our house, and then it's worn out, it's gone, its life, useful life is gone, we'd send it to the dump. So it gets manufactured, it goes from the store to the dump. Nowadays, products, there's companies that'll come in and design for manufacturers exactly how to do this, though, is to design products so that when it's gone its useful lifetime, you can recycle the materials that are in it. So that's what's cradle to cradle. Instead of going store to dump, it goes store to recycle to the store again, something else. That's what cradle to cradle is all about. It's a whole concept. And in this house, these headers we put in, they're decorative, architectural, but these were 6 by 18 clear, solid redwood beams that I had bought years ago in the 70s at a house recycling company that's not there anymore, downtown San Diego. I used to like to browse through it because they had sinks and doors and windows that they'd taken out from homes. And they had just gotten in a pile of about 20 of these big, long beams, and it was all black. They're all black. And they demoed some bridge down in Balboa Park somewhere. And the house recycler brought these in. And somebody had bought one and took a skill saw and ripped it open. And And I did a double take walking by, and then you could see the redwood. So I bought like 18 of these beams. Didn't know what I was going to use them for, but we used them here in this house. So that's kind of like recycling. Okay, indoor air quality. Most of us spend 90% of our lives in the house. Indoors. We're indoors right now. Most of us work indoors. So too often, the indoor air quality inside the building is 2 to 10 times worse than it is outside. So it's really important to pay attention to indoor air quality. You want to seal your house from the garage, so pollutants in the garage like paints and gasoline and carbon monoxide from your car don't get into the house. Formaldehyde free products and low to no VOC products. VOCs is volatile organic compounds that off-gas from products. The example I like to use on that, VOC is like when you buy a new car and you like the new car smell, and it doesn't have to smell bad, but it's not good for you. That's off-gassing of VOCs. It goes away after a while, but products, we try to use products that have no to low VOCs, and direct vented combustion equipment. In Ramona, we use drywall. CertainTeed makes drywall, and it is more expensive. But there's a type of drywall that actually absorbs VOCs. Because the thinking is you build a nice LEED house that's free of VOCs, then people move in and they bring in carpets and they bring in furniture and household products like cleaning products and all sorts of things that off-gas gases. So that this drywall actually absorbs VOCs and there's a chemical in it that makes it inert. So it's pretty interesting. I didn't know that until we came across that. Indoor human health, you want to manage your pollutants. You want to try to ventilate the moisture and so forth that comes out of kitchens and baths. And we do that with mechanical ventilation. In Amy's house, Amy and Pete's house, we have a heat recovery system. That's a balanced ventilation. A lot of times people just use exhaust ventilation. Well, if your house is closed up, that creates a negative air pressure in the house, which tends to want to draw in unwanted air from the outside. Balanced, an HRV, it's taking, we do the exhaust out of the kitchens and baths, and we're bringing air in at the same time from the outside, and then there's a heat exchange so that you don't, you have cold air coming in the winter, you want to heat that air coming in from the air going out, and vice versa in the summer. And it just makes a really, really fresh, clean feeling house in the air. And I have a hard time, people go, oh, I just leave my windows open all the time. So I don't need that. Well, what are you putting a heating system in for then? At some points, and if you air condition your house and you heat your house, you got everything closed up. You need ventilation for it. And then MERV filters. There's different degrees of filter that clean the air better, but then you have to be sure and change them out. Radon control is another subject. So manage the moisture, talked about that, and vapor retarders. And daylighting is important. It's just, look at this, is a classroom that they built, school of some sort, and you don't see any lights on in there. Instead of a building like this that we're in, even during the day you need lights on. Whereas if you do daylighting and let that light come in, you not only save energy, it just feels better, and it gives you a little more connect with the outdoors to the indoors. So those are the 5. You've got, where to go? I think this is sight here, water, energy, indoor air quality, and materials. So everything falls in those categories. And once I kind of got that in my head, I felt like it really helped. I hope it helps you to understand what green features go into a building. And green buildings, they're healthier, you have cleaner air, and they're more comfortable to live in. You don't have ups and downs of heat and cooling. It's just a nice, comfortable feeling and fresh air if you ventilate it right. And they're durable so that they last longer. You have lower maintenance costs and energy efficiency. They don't cost as much to run. Your utility bills can be very little. And it's environmentally responsible. The green home cuts energy usage, I think even more than that, but 24 to 50%. I came across this slide somewhere. CO2 emissions almost 40% water use, but 40% in solid waste. That's waste materials when we build it, 70%. So there's different, let's talk a minute about the rating systems, briefly. LEED for homes, Leadership in Energy and Environmental Design, has a rating system from about 5 different categories, and you get points to grade it along the way. It's by the United States Green Building Council. It's a national rating system, and around here it's pretty prestigious. Passive House is LEED a little bit on steroids. When I said back in the 70s, when we had energy efficient measures, America's pretty innovative, and then we started coming up with innovative ways to start saving energy efficiency, because they'll get off the oil from the Middle East is controlling our energy. Everybody starts going, whoa. And we came up with a lot of things, but then it got cheaper again, it went away. But in Europe, it stayed expensive. So Europe took what started in the United States, those principles, and built on them, and continued to build on them, and they developed this passive house certification. Started in Germany, and it's a way of building a house and modeling it and doing all these things, super insulated, super airtight, and super insulated, and modeled correctly that you need no mechanical system to heat that house even in the winters of Germany. And then about 10 years ago, it came to Chicago. A lady from Germany brought it over to Chicago and started it in the United States. Greenpoint Rated is a California system. It's very similar to LEED. They really overlap. They're all trying to achieve the same thing. It's a little easier thing. It's very inexpensive to do. But the thing with the rating systems is you have third-party verification so that you actually know that you're doing it correctly and you're going to benefit from what it's about. National Association of Home Builders has their own thing that's very similar to LEED, but it's not used around here as much. It's more on the East Coast. So rating. It's a tool. It sets targets and tracks progress, both in the design and the construction of the house. It's a scorecard. It's like the nutrition labels on food in the store. You got a clear picture of all the different things, issues that are green about it, and it's certified by a third party. And it gives you confidence that it's going to perform the way it's supposed to. So that's why I promote rating systems. And like I said, it's not about chasing points. It's just to deliver a better product. And that's the house of the future. And this is a little graph that you don't have to pay attention to. But they have different rating systems according to how many points you get. And each one costs a little bit more, and some are quite a bit more. But that's when you start doing the high-hanging fruit. These ones just take the low-hanging fruit. And that's why we put this together, that you actually need to do the low-hanging fruit, low-hanging being the inexpensive, easy to do. It makes sense to do that first. You don't put an expensive photovoltaic panel on a house that's a leaky house with inefficient lighting and gobbles up energy. You can make any house net zero by putting a whole bunch of PV, but it doesn't make sense to do that. So you do all these low-hanging fruit first, and then you go to the others and work your way up. And that's kind of how Casa Aguirre ended up doing them all. So that was the high-hanging fruit. And I like to end with this one, because I really believe it's true. If you build or remodel a home today and it's not built green, it's obsolete the day it's completed. Questions? Thank you.
Thank you.
That was 55 minutes.
What was the name again of those gel sheets?
Phase change material.
What?
Phase change material.
And how thick?
PCM. Huh?
How thick are
They're about this thick. So it just pushed into that cellulose a little bit when we put the drywall on. So it just, because the cellulose gives a little bit.
they? All over the insulation?
Yes. Yeah, you insulate it first, put that up, and then drywalled over it. The gels go there. It's kind of like a waffle. They're like little packets on one, not this big, but little packets all on one side. We put that to the insulation, and it's flat on this side. And you just staple it to the studs. And it does cost more, but it's not too bad. And that house, we did it in the ceilings and all the walls because we got a discounted, they were like a sponsor. We got a discounted price, but you really don't have to do the whole house like that. You can get a lot of benefit by just doing some strategic walls. And the company we get it from will help analyze the house and tell you which walls to do and how much to do.
I have several questions, but I'll just ask two right now. One is overall costs up front to either new construction or remodel, covering a couple of those low-hanging fruit compared to conventional, and then also specifically the cellulose insulation costs versus typical fiberglass.
Yeah, I'll start with the cellulose. It is a little bit more. God, what percentage? It's maybe 3 times as much as bats. Bats are pretty cheap, but I really recommend, in the overall sense, percentage of cost of the house, it's really worth it. It's not very much. Insulation is basically a very inexpensive product.
It seems like that's a big part of that envelope.
It is. It is. And your air sealing, low-hanging fruit, I call that low-hanging fruit because it's just really having it in your head and paying attention to the details. Get that concept of the balloon and make sure all those openings are closed in your house. That's not expensive to do. Some caulking, a little bit of spray foam.
I think there's a test you can do when you first do it, and then when you're done to compare the...
A blower door test. We do
Yeah.
blower door tests on all our projects now, yeah. And these homes, we just finished one in Encinitas. I couldn't talk her into heat recovery ventilation system, HRV, and I wish she had. But when she moved in, without soliciting it, she goes, yeah, boy, this house, I just love to feel this house. It just stays this constant temperature. And that was because of the air sealing. In that house, it was a gut remodel. She had 2x4 walls, only 3.5 inches thick. So to get the insulation value we wanted, we sprayed 1 inch of closed cell foam. And by doing that, that actually air sealed the envelope on the walls. And we did it on the ceiling too. And then did the rest with cellulose. And it works really great.
And didn't they...
Closed cell foam costs more too.
Didn't they recently just in San Diego County change the building codes that you now have to put rigid foam?
That's coming.
Okay,
Yeah, the new Title 24. Yeah, that's coming.
When's that happening?
I'm not exactly sure.
It's kind of a good
My
thing.
partner Rich would know. But yeah, that's around the corner. We're thinking about how to do that, yeah.
So I think SDG&E will come into your house and do an inspection for free, and they'll do a lot of that sealing off.
Really?
And, yep,
I didn't know that,
call
yeah.
them, and I don't know if they're still doing it, but they saved us a lot of money.
Oh, you did that?
Yep.
Oh, that's great. Okay.
You're talking about low-hanging fruit. There was a presentation we watched by a guy that would come into a house prior to putting the solar on. It would go through and change all the lighting to LED.
See?
The cost, and he was not cheap, but the cost of the LEDs was more than recovered by the reduced cost of the solar installation.
I was at a lady's house in Palm Desert, and she's going, yeah, I got to get some, it says these high electrical bills. She's got an air conditioner in her house. It gets really hot there. And she says, so how much to put the photovoltaic on the roof? And we're walking in her house, and she has these incandescent lights and kind of a low ceilings, and it's hot. It's giving up all this heat. We're going, change your lights first. Yeah, that's the low-hanging fruit. Yep. Do that, and you'll use less energy. You need less PV panels up there. So.
Yeah, along that lines, we had put in a bathroom that had 2 Ken bulb setups. We put in regular incandescent bulbs. And you'd walk in there and turn it on, and you get this radiant heat. We swapped them out to CCFLs, and you walked in and turned it on, and it actually felt cold because you're so used to that plastic heat coming in.
Yeah, that's right. That heats the inefficiency of them, yeah.
Where is a good resource in San Diego area to find resources? Like if you own a home and you want somebody to come in and do, find an electrician who's going to come in and do a good job of changing out your lights and not just doing, a poor job. Where's a good place to find?
Give me your email. I'll email you some people that will come in and do a site analysis of more than just the lights, your whole house.
Okay.
There's people that do that very thing. And they'll give you a whole report about the whole house and all these issues and how they relate to your house.
Yeah.
There's people that do just that.
Okay, great.
We had a poll in this county a while back on Lilac Hills. And the issue was, what is the effect of greenhouse gas emissions by constructing this thing? And I saw in your presentation, you have a building allocation of where the energy is used in building.
Uh-huh.
There was I don't know if it was a court case or not, but the builder was very concerned, how is he going to estimate the greenhouse gas emission of his building? And why would we use that to stop him from building? Well, now there must be techniques to be used to estimate what is the additional greenhouse gases during the building process. You can build homes that are LEDs, but there's still going to be that bulge, that bulk, the greenhouse gas.
Yeah,
Big-
I think what you're talking about is called in the embodied energy. There's embodied energy in products, like how much energy did it take to produce this, or carbon off-gassing, pollutions from carbon, to create a product. And then you apply that to your whole house. I think that's what you're talking about. And there's whole books written about that, and you can really go down a rabbit hole trying to figure out the embodied energy, because there's a lot of things to think about. It's like bamboo is a renewable resource. It grows real fast, but it's from the other side of the planet. So there's embodied energy to transport it over here. That's kind of...
Construction costs. That would be pretty easy to estimate on a large scale.
Yeah, I don't know. I have never done that. It's a good point.
Yeah, how many gallons of gas you use in the generators to power the power tools while you're building? Probably gonna get pretty good.
Yeah. Yeah, or how many cubic yards of concrete went into the house. At one point, we were tracking that for Casa Guia, and all the energy that goes to create that concrete. And that's kind of the embodied energy of it. That I haven't gone down that rabbit hole. Marion?
I'd love to figure out how to use that phase change material in my house that's already built, because I saw it on that house tour. I was just so taken with it. And so how would you incorporate something like that into a house that's already been built, such as ours? Is there a way to do it?
I don't know.
Just overlay it on your existing walls, I would think.
If you want to see it.
Yeah, I know. So it'd be interesting if we could figure out, because I think a lot of us here probably aren't going to be building new homes. We're going to be wanting to improve the houses
Yeah.
that we have. So it'd be really great if there were some sort of resources, through your company or, for people that are in the situation that Steve and I are in.
Well, like, and where you want to put it, first thing I think of is like kitchens, where the heat comes off a kitchen. I heard they use it a lot in restaurants, in the hot kitchens, and help keep that heat down. So you could put little furring strips and put it up and then re-drywall. Well, it's just a
Could
thought.
it have to be behind drywall though, or could it be behind the paneling? I don't know exactly how.
It could be behind paneling, yeah.
Okay.
Yeah.
You'd have it on the wall out in the open, just for
Yeah.
people to look at it all the
Yeah,
time.
no, I don't want to do that, so.
You just carpet with it. Huh?
Yeah.
What do those cost, like for a 4x8 panel of the phase change thing?
Well, it comes in rolls like 16 inches wide, so you can staple it to or 14 and a half inches wide,
Okay.
staple it to your studs. I don't know, it's a good question per square foot. It's a little pricey. That's why I say you don't have to do your whole house. You could get benefit from it. I have a great resource for it if you want to know who to talk to about that.
And again, just roughly, if you're just talking about some of the low-hanging fruit, the overall cost.
Oh, yeah, back to your original question, yeah. It's not as much as people think. It's not that much. Like I was talking about, sealing the house is this tremendous thing. LED light bulbs are inexpensive. Energy Star appliances really aren't any more expensive than others. So it's not that much. In fact, Rich and I want to try and figure out, model somehow, and try and prove that it can actually cost less money to do green. Especially like in passive house, which does cost money. The concept is you use more insulation, you air seal it, you use more insulation, but you don't need as much mechanical. And insulation is a lot less cost than mechanical equipment. So that would be a cost savings. But yeah, it's the low-hanging fruit. It's very inexpensive to do.
And do you have that chart, like on your website, or?
I don't think I do, but I can give you this I can email you the PowerPoint.
Okay.
Everybody's welcome to have this. So you get like you folks, the Climate Action Committee, you get it, the sustainability. That's why you get passionate about it, because, God, it's, it's life and death. It's our planet.
Things have changed since we put our solar panels on, but if I could do it again, I would put more solar panels than we really needed, because we always have a use for that extra electricity.
Yeah.
Rather than give it back to SDG&E, so.
Yeah. Okay, well, thank you very much.
Thank you.
It's an honor to be talking in front of your group.